questions 11 through 20 of the 1999 Grade 9 Pascal Math Contest. Today is Wednesday. What day of the week will it be 100 days from now? So we'll draw a little calendar, and today is Wednesday. And what they're interested in is 100 days from today. So 1 day from today is Thursday, 2 days is Friday, 3 days is Saturday, and so on. Now, I'm not going to write out all 100 days, but you'll notice that once you get back to Thursday, it's an 8. So essentially, we just went from 1 to 8 by adding 7 days. So you can keep going like that and add multiples of 7. So 15, 22, like that, 29, 36, 43. All of these days will be Thursdays. 57, 64, 71, 78, 85, 92, and then finally 99. And then 1 day after that is 100. So this is the day that they are interested in, and that will be a Friday. So the answer here is D. The time on a digital clock is 5:55. How many minutes will pass before the clock next shows a time with all digits identical? All right, the next one is 666. But of course, there's no such thing because the maximum, as we all know, is 60 minutes. Same thing with 777, 888, 999. There's no such time. But after 9, we get to 1. How about 1111? That is indeed when all digits are identical. So we want to know how much time has passed from 5:55 until 11:11. Well, very easy way of doing this, from 5:55 to 6 p.m. exactly, or 6 a.m., I don't think they even tell us, is 5 minutes. And then from 6 to 11 is 5 hours, exactly. And then finally from 11 to 11:11 is 11 minutes. And these answers that they've given us are all in minutes. Yeah, how many minutes? So we have to convert 5 hours to minutes, and that's 5 times 60, which is 300. So 5 plus 300 plus 11 is 316 minutes, is how much time has passed from 5:55 to 1111. So 316 is answer D. In Circle Land, the number 207 and 4520 are shown in the following way. In Circle Land, what does the following diagram represent? All right. So I think what's happening here is that whenever there's a circle around a number, it represents a power of 10. And when there isn't a circle, it's just a standalone number. So this 7 that they have here is just 7. But this 2 that they have there is 2 times 10 to the power of 2. Why? Because there's 2 circles around it. So I hope that makes sense. So similarly, this 2 is 2 times 10 to the power of 1, because there's 1 circle. This is 5 times 10 to the power of 2, because there's 2 circles around the 5. And this is 4 times 10 to the power of 1, 2, 3. 3 circles, or 3 as the exponent. So if you do this, you'll get 4,000. This is 500, and this is 20. And if you add these numbers up, you get 4,520, which is exactly what they've given us. So now they want us to do this one here. All right, well, the 5 is just a standalone 5. There's no circle around it. The 1 will be 1 times 10 to the power of 2, because there's 2 circles. And this 3 is 3 times 10 to the power of 1, 2, 3, 4 circles. So this looks like 10,000 times 3, 30,000. This is 100 times 1, which is 100, and this is 5. So if you add up these, you get 30,105. So the answer would be A. An 8 centimeter cube has a 4 centimeter square hole cut through its center, as shown. What is the remaining volume in centimeters cubed? Okay, so we have to first figure out the total volume and then subtract from it the cut part, whatever you want to call it, the cut part. And that would give us the remaining volume. All right, so the total part, I'll do it over here, it's a cube, right? So just the volume of a cube is just x cubed, where x is the side, and x in this case is 8. So we got 8 to the power of 3, which is 512. Yeah, 8 times 8 times 8, basically. Now the cut part, the part that they've cut out right here, as they're illustrating right there, that part there. That part is not a cube, it's a prism, a rectangular prism, whatever. And that part we can calculate the volume of, similarly, with a length times width times height formula. Length is 4. Width is 4 right here, and the height is just basically top to bottom, which is 8, like that. So 4 times 4 times 8 is 128. All right, so now we go back. Total is 512. The part that they cut out is 128. And therefore, 512 minus 128 is 384. So the answer here would be D. For how many different values of k is the 4-digit number 7k52 divisible by 12? All right, so 7k52. And k obviously is a digit, so k can be anywhere between 0 and 9. So we can write out all of these very quickly. 7352, 7252, 7452, 7552, and so on. And essentially what they're asking for is how many of these are divisible by 12. So if you divide by 12, are you going to get a whole number or not? Well, this first one doesn't give you a whole number. It's 587.6. The next one divisible by 12 is exactly 596. So this is good, this one. Next one divisible by 12 is 604.33. So that's no good. How about the next one? 7352 divided by 12 is 612.66. 7452 divisible by 12, yes or no? It's 621, exactly. So yes. 7552 divisible by 12. So you just keep going like this and see which ones are divisible by 12 by giving a whole number. 7652 is 637.6. 7752 is exactly 646. 7852 divided by 12 is 654.37. And the last one is 662 divided 0.6, like that. So how many of these are whole numbers? Well, we got 596, 621, and 646. So only 3. The only values of k for which 7K52 is divisible by 12 are 1, 4, and 7. So 3 values. So 15, the answer is D. In an election, Harold received 60% of the votes and Jackie received all the rest. If Harold won by 24 votes, how many people voted? All right, so I'll let X represent the number of people who voted. And Harold, H, received 60% of X, which is the number of votes. And then Jackie, J, represents the rest, which is 40% of the votes. All right? And then we also have been told that Harold won by 24 votes. So Harold had 24 votes more than Jackie, like that. Okay? So now we can plug in these values into this equation. So H is 0.6, X, and J is 0.4x plus 24. Subtract the 0.4 from the other side and you get 0.2x is equal to 24, and therefore x is 24 divided by 0.2. So x will be 120. So now we have to, I think that's it. 16, they're asking how many people voted. All right, we got it. Okay, sometimes I overthink the question. So 16 is E, and that's it. All right. In the parallelogram, the value of X is, okay, let's draw this out a little bit bigger, like that. And there's several ways of doing this. I'm just going to do it this way. I'm going to extend this line right here and just start labeling this now. So these lines are parallel like that. And this is 80. They've given you that. They've drawn another line in here, interestingly, right here. And they've labeled the angles X for right there. And this whole thing is 150 from here to here. Okay. So now it's up to me to figure out the rest because I think I've exhausted what they've given us. So the first thing I notice immediately is that if you have a line, all the angles about that line like that are going to be 180, the sum. So this angle in here, I'll call it Y, plus 150 has to be equal to 180. So therefore Y is 30. All right? And then because this is a parallelogram, these are all parallel. If this is 80, then that means that this angle is 80. Right? That's just a fundamental property of parallel lines. And then similarly, if you draw this pattern here, these are also parallel, these ones, these lines. If this is 80, this will be 80 also. Okay? That's very important. That's how you sometimes prove that two lines are parallel, by the angles, comparison of the angles. So now finally we have all the angles in a triangle except one, and therefore we can solve for the unknown. So in that triangle, x plus 80 plus y is equal to 180. And therefore x plus 80 plus y, which is 30, that we calculated there, is 180. And therefore x is equal to 70 degrees. So the answer is C. In the diagram, AD is less than BC. What is the perimeter of ABCD? All right. The first thing I'm going to do is drop a perpendicular from D down to the base like that. And this is therefore a right angle. Now, if this is 4, that means this is 4. And then I hope you can see a relationship in this triangle right here. This is a 3, 4, 5 triangle. And if you didn't know that and you still were not convinced, you can do Pythagoras. You can say 4 squared plus x squared is equal to 5 squared, and therefore x squared is equal to 25 minus 16, and therefore x squared is equal to 9, x is equal to 3. So in either way, x becomes 3. If x is 3, and then this part is 7, we now have all the sides of this shape, ABCD. So the perimeter will be 7 plus 5 plus this whole side, which is 7 plus 3, which is 10, and finally this, which is 4. So this looks like it is 26. So the answer here for 18 is B. The numbers 49, 29, 9, 40, 22, 15, 53, 33, and 13 and 47 are grouped into pairs so that the sum of each pair is the same. What number is paired with 15? Okay, so they've given a whole bunch of numbers here, and the first thing I want to do is figure out what is the average of all these numbers, because that's going to help me figure out the value of each pair. Plus 33 plus 13 plus 47, all divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you do this, you'll figure out that this is 31. So the average of these numbers is 31. So therefore, a pair will have two numbers, and therefore the sum of the pair will be 2 times 31, which is 62. So what number is paired with 15? Well, 15 and some other number have to equal 62. So 62 minus 15 is 47. And if you do all of these, you'll find that the numbers are 15 and 47, 13 and 49, all the pairs, just in case you're wondering, 9 and 53, 22 and 40, and finally 29 and 33. So when you take all these numbers and group them into pairs, they're like that, and each pair has the same sum, and that sum is 62. So the answer to this question was 47, which is C. The units, ones digit in the product of 5 plus 1, 5 to the 3 plus 1, 5 to the 6 plus 1, and 5 to the 12 plus 1 is, all right, 5 to the 1 plus 1, I guess, 5 to the 3 plus 1, 5 to the 6 plus 1, and 5 to the 12 plus 1. There's a couple ways of doing this. That's 6. That's going to be 126. That's 15, 626. And then this one is a big long number, 244, 140, 626. When you multiply anything by 6, like 6 times 6, it always becomes a number that has a final digit of 6. So even before I multiply all this, I know that at the end, the big long number that I get, the final digit is going to be a 6. And you can easily do this on a calculator. They're just trying to see if you can do this quickly, intuitively, by looking at the last digits. And I did. But just for the sake of completion, let's write out this number. It's a big long number, 938, 714, 095. The number really isn't important. What's important is the final digit, the ones digit or the units digit. And you can figure that out even without having to do this whole thing, just by looking at the units digits of each term and figuring out that 6 times 6 times 6 times 6 is going to be a number that has 6 as the final digit, or the units digit. So the answer to number 20 is A.